So welcome again. In this video I'm going to introduce R. You might have joined this course to learn how to do statistical analysis in R, or you might have no idea what this is about. In any case, I believe it will be a very helpful part of what we're going to spend our time on. So what is R? R is a statistical programming language. But don't be too worried about the idea of a programming language. It can ultimately serve as a calculator as well. It's a way of doing analysis. It's an open source project, which means that a whole community of academics, of programmers, have volunteered a lot of time to build this up over the last 26 years. It also means that anyone who needs something can build their own part of it. So R consists of a base that has been growing over the past 26 years, many extra packages where people have developed new specific applications, which we can all download and use now for our own purposes. And then there are various interfaces. Because R used to be just a command line where you type things in and you get responses, but now there are many interfaces that make that easier. RStudio is probably the most popular one, it's the one we're going to use in this course. Why are we using R? Well, because it's just very powerful, either in the base or through the packages, for statistics, for other parts of data science, and for visualization. There's basically no other package that combines all of these aspects. And also there's a very active online support community. So when you struggle to do something in R, in this course obviously ask questions, but outside there are so many different resources. For example, Stack Overflow, which is an online forum where many people discuss issues with R. Using a coding language like R, rather than something like SPSS or Excel, allows us to do reproducible research. So once you have done your analysis, it's very easy to pass it on to someone else who can help you, who can continue your research, but also to pass it on to the research community who might want to challenge it, who might want to check whether your results are robust. There's more and more of a trend in science towards open and reproducible research, and using a statistical programming language rather than something with a graphical interface helps you to be part of that trend. And R is by now statistically the most demanded an analysis tool in job adverts, and it's becoming more and more popular in journal articles across disciplines. So it's a really helpful thing to learn. To learn how to use R, the most important thing is to actually use it to practice. And for that it's very helpful if you can install it onto your own computer. To do that, you need to follow 3 steps. The first is to actually download R from rproject.org, where you get the base package for everything that's happening under the hood. Then you probably want an interface that makes it a bit easier to use R, that gives you things beyond the command line. For this course we're going to use RStudio, which you can download from rstudio.com, just take the free version there. Thirdly, once you've opened up RStudio, you'll need to install some extra packages, and that's something that you will be doing throughout your time of using R. Some of these packages are very small, some of the packages basically change almost everything about R. For the start, I encourage you to install 2. The first one is called DS Labs. That's just a package with a bunch of datasets that we're going to use for the class projects. The second one is the Tidyverse. The Tidyverse is probably one of the biggest packages in R that has all kinds of things. At the start, we will just use one small part of it, which is ggplot2, which is the best package for making graphs, for doing visual data exploration, and then later on also communication. Once you've installed RStudio, it's worth having a look around. It can look overwhelming with all the different windows, all the different options. Actually, we're going to only be using a very few of them. I'll just spend a minute pointing out some of the important ones. So the console here is where we actually interact with R. Whenever it shows the greater than sign, it's ready to receive commands. Those can just be simple calculations, or they can be commands like the one to install packages. For such commands, we need to provide details in brackets, in this case, the name of a package, in quotation marks. So if you can install the tidyverse in your own RStudio, that will make it easier to carry out the exercises in class. With such commands, you might be getting a lot of output. At some point, R will be done, and when you get the greater than sign again, you can continue your work. To use a package, we'll actually need to then load it using the library command. In all these cases, you can get a tooltip, a selection of all the options that start with the letters you have typed, and can select your choice within the tooltip. In the console, you can also save values into variables. More on that in the video in a second. But I want to use it to point out the second relevant window here, the environment. In the environment, you can see all the values that are currently set. When working with a lot of data, there would of course be a lot more in here. It's good to keep an overview. Lastly, we'll be using a lot of functions. We already have used install packages, we've used library. There are lots of mathematical functions like mean to calculate an average. For all of these functions, you can get help by typing question mark and then the function name. Once you have done that, a help window here is going to open up with more details on the function. Since typing the same commands into the console again and again is a bit of a waste of time, you can create files. R scripts or notebooks are the tools we're going to use, where you then type your commands. After you've typed them, you can run them by clicking on run, and they will again be run in the console. The results will appear there. We'll do a lot more on all of that in class, and you will get a chance to ask any questions. As you have just seen, it's quite easy to use RMarkdown files in RStudio, and I'd highly encourage you to do that, because RMarkdown files help you to very easily transform your analysis into nice documents. And it's good for a range of reasons. So for one is just that it helps you to keep everything together. Can keep your code, your results, your reporting on the results all in one document. It can help to keep the analysis very clear and reproducible, and therefore of course also save a lot of time when you realize that you need to update the data, when you realize that you forgot one particular setting, which in some other software would require you to just do everything again all over. In these RMarkdown files, you can have blocks of R code that are labeled as R, and then you can have all the other things in between. Once you have that, you can easily convert it into PDF reports, into HTML files, and we will use that for the exams and for the homework. And I'll expect you to submit these RMarkdown reports. We'll of course practice it in class. So how do we deal with data in R? Usually of course we load in big data sets. At the beginning we might sometimes enter data manually, but there are three different types of data to be aware of. One is called scalars. Scalars are just individual values. You would just assign an individual value to a variable name in R, as shown here, and then you can use that in any calculations. You can print it out again. It's not very common, but sometimes we use that. Already a lot more relevant and helpful are vectors. Vectors are just chains of similar values. They all need to have the same data type, so they all need to be either numeric or categorical. But it also wouldn't really make sense to store mixed things in a vector. So one thing to have in a vector could, for example, be the heights of the people in our sample. And then we can easily do calculations across this vector. Mean here just gives us the average height of these people. And then the third is a data frame, which is basically just a combination of vectors. That's where we would store all of the variables relevant to one particular project. So here in the most simple case, we would have an exam data frame that has two variables. It has a name and it has the score that that person obtained. str here is a function to just look at what's going on inside the data frame. So we'll be using that a lot when we start on new data to see which variables are there, how many values, and so on. But these three types of data will accompany us throughout. Scalars for individual values, vectors for groups of similar values, and data frames for whole data sets. Functions are then what we use to actually work with these values. They always do something for which they typically need data. This function just prints a little greeting out. And this data, as well as any other instructions, are provided in brackets. So in this case, the mean function gets data, ages, and it gets an instruction, na.rm, which means remove missing values, which we say true. So in this case, we instruct it to remove missing values. In any case, any function gets data and other instructions, if any, in brackets right after it. The results that a function returns can of course be again saved in a variable for then future use in our analysis. A couple of things to get started, which we'll practice in class, but if you remember them, it will save you quite a bit of frustration when things don't go the way you expect them to go. So the first thing is that this less than minus combination of characters means a sign. So we use that whenever we want to take some kind of value, some kind of data point, and assign it to a variable. In that, it's important to remember that R is case sensitive. Price and these different spellings would give us 3 variable names. So it's really helpful to develop a consistent approach to that. Some people use no capital letters ever. Some people use capital letters for the second word and any further words in a name. Use your own approach, just try to be consistent. And then text needs to be written inside quotation marks. If it's not, I will throw an error and you can't move on with your analysis. You can use single or double quotation marks. That doesn't matter, it just needs to be consistent. And a couple more things is that we use the $sign to access individual variables in a data frame. So here, if we're interested in the exam scores, we would write exam $score, and then we can calculate the mean of the exam scores. When using R, help is always available. For very specific things within R, you can type question mark and then the command, and it gives you an explanation of how to use that particular function, and how to use any of the arguments, any of the extra instructions. Apart from that, there are a couple of books on the reading list, many of which are just accessible online, so easy to use. There are lots of web pages. There's Stack Overflow that I already mentioned. There's R bloggers that collates lots of people blogging on R. Generally in these online forums, people are very willing to help, but it really pays fruit to first Google to see whether someone else has asked exactly the same question, because obviously all these people are volunteers and they can get a bit frustrated if they waste their time. Of course, while we're doing this course, you can always ask in class, and we'll use all of the things that I now very briefly introduced during our exercises in the first class. So I'm looking forward to seeing you then. Please do try to install R and bring your laptop so that you can work in your own customized workspace. See you then.